The map of our world is about to change. I'm talking about the continent of Africa splitting into two.
Africa is undergoing a transformation so profound that it's literally reshaping the continent itself. Deep beneath East Africa, the Earth's crust is fracturing, splitting one of the largest landmasses on the planet into pieces. The Somali and Nubian tectonic plates are slowly drifting apart, and while this rift is expanding at an almost imperceptible rate, it's paving the way for a brand new ocean. Yes, an ocean that could redefine the geography of our world as we know it. What triggered this global awareness? Scientists have been closely monitoring this phenomenon for decades, but recent developments have captured the attention of the world. The tectonic activity in the Great Rift Valley is not just a geological event, it's a glimpse into Earth's distant future. This slow-motion split has already begun to create massive fissures in the ground, visible evidence of a process that could take millions of years to complete. Imagine standing on the cusp of history, witnessing the formation of what will one day be a new ocean basin. This isn't science fiction, it's the raw power of nature at work. While the timeline may stretch beyond human lifespans, the changes we're observing today provide invaluable insights into tectonic processes and their global impact. The implications of this phenomenon are enormous. Over time, as the plates continue to pull apart, East Africa could separate entirely, creating a new landmass surrounded by a vast ocean. For now, though, this ongoing transformation serves as a stark reminder of our planet's dynamic nature. Stay tuned as we dive deeper into what this rift means for Africa, the world, and the generations to come. The 2005 Daboo eruption. The seismic activity leading up to the 2005 Daboo eruption was nothing short of extraordinary. In September of that year, the Daboo area, nestled within the Afar Depression in Ethiopia, became the epicenter of a cascade of earthquakes. Over 130 tremors shook the region in just a single week. These weren't minor rumblings. They were powerful precursors to a geological phenomenon unfolding beneath the surface. For the communities living in this remote area, the relentless shaking brought both alarm and confusion. Without warning or explanation, the ground seemed to turn volatile overnight, rumbling continuously. Each quake was a dramatic signal, a burst of energy released as the Earth's crust began to pull apart. Deep below, tectonic plates were diverging, creating fractures that allowed magma to surge upward. Scientists around the world took notice as their instruments recorded this rare alignment of seismic and tectonic events. While earthquakes in tectonically active zones aren't unusual, the sheer concentration and intensity of these tremors pointed to something far more significant brewing underground. Then, on September 26, 2005, the Daboo volcano erupted. Magma forced its way to the surface with immense energy, releasing ash, molten rock, and gases. Although the eruption wasn't explosive by global standards, its geological importance was unparalleled. Massive fissures split the ground wide open, leaving cracks so deep and expansive that they were visible to the naked eye. This eruption displaced approximately 6,300 people, forcing entire families to flee as their homes and farmland were swallowed by the shifting earth. For many, the loss of livestock, a vital source of livelihood, made the situation even more dire. Relief efforts faced significant challenges reaching the affected areas, highlighting the vulnerability of those living in this geologically volatile region. Amid the human suffering, the global scientific community focused on the groundbreaking revelations the event offered. Over the days following the eruption, 37 miles of fissures carved their way across the landscape. These weren't shallow cracks. They extended deep into the earth, exposing molten rock and thermal activity. The ground itself shifted dramatically, with sections moving meters within days. Satellite imagery and ground observations revealed a surreal transformation. For geologists, this was a once-in-a-lifetime chance to observe plate tectonics in real time. The eruption and subsequent rifting were driven by the divergence of the Somali and Nubian plates. As these plates drifted apart, the thin crust above them fractured, creating channels for magma to rise to the surface and fuel the geological drama. This event became an extraordinary opportunity to study rifting on a human timescale. Unlike most tectonic processes that unfold over millions of years, The activity at Daboo occurred over days, weeks, and months, allowing scientists to capture and analyze every stage of the process. GPS sensors and seismic equipment recorded data that confirmed these 37 miles of fissures were the first stage of a new ocean-forming rift. The Afar region was essentially laying the groundwork for the eventual creation of a new sea. This wasn't just a local event, it was a vivid glimpse into Earth's evolutionary processes, offering invaluable insights into how landmasses split and oceans are born. The 2005 Daboo eruption proved that Africa's rifting isn't theoretical, it's happening right before our eyes. The Somali and Nubian plates, once thought to be locked together, are actively tearing apart under immense tectonic stress. The surging magma acted as a catalyst, pushing the plates further apart and accelerating the rifting process. While the Daboo eruption was a turning point for scientific awareness, it marked only the beginning of an unfolding story. The Afar Depression remains a unique geological hotspot, destined to shape the continent's geography for millennia to come. What secrets will this remarkable region continue to reveal? Understanding the East African Rift. The East African Rift is one of the most breathtaking geological marvels on Earth, stretching an astonishing 3,000 kilometers from the Afar Depression in Ethiopia, through Kenya and Tanzania, all the way to Mozambique. This colossal rift isn't just a geographical feature. It's a living, evolving boundary between two tectonic plates, the Somali plate, drifting southeast, and the Nubian plate, moving northwest. Far from being a static line on a map, this rift is a vivid display of Earth's raw power and constant transformation. It represents a dynamic process where the planet's crust is actively tearing itself apart. What's even more incredible is that this phenomenon isn't locked in the distant past. It's happening right now, unfolding in real time. The East African Rift's story began millions of years ago, but today, it stands as a gateway to understanding our planet's evolutionary journey. With every tremor and every crack that appears in the Earth's surface, we're witnessing the birth of a potential new ocean, a process as humbling as it is awe-inspiring. This is Earth's way of showing us that nothing in nature is ever truly still. It's a constant, magnificent work in progress. How the rift works. The East African Rift isn't just an impressive geological feature. It's an ongoing, dramatic process that's actively reshaping the landscape and offering us a rare glimpse into Earth's dynamic evolution. What makes it so unique isn't just that it's splitting the African continent in two, it's also creating entirely new geological structures, like valleys, fissures, and even future coastlines. Unlike the slow tectonic shifts we see elsewhere, the rift's activity is happening fast enough to be observed within a human lifespan. At the heart of this transformation is magma. Deep below the surface, molten rock rises from the mantle and intrudes into the rift, applying pressure that forces the Somali and Nubian plates apart. As the plates drift, the crust in the rift zone becomes thinner and more fragile, cracking open to form massive fissures. These openings allow magma to flow in, cooling and hardening to create new crust, forming a continuous cycle of destruction and renewal. It's like nature's conveyor belt, constantly adding new land as old crust is torn apart. But it's not just magma that's driving this process. Gravity plays a huge role too. As the rift widens, parts of the Earth's crust sink under their own weight, creating dramatic escarpments and deep valleys. These valleys often become filled with water, forming iconic lakes like Lake Tanganyika and Lake Malawi, which trace the path of the rift. The result? A breathtakingly diverse landscape, full of volcanic activity, hot springs, and incredibly fertile soil. The process of rifting is far from complete. Over millions of years, the rift will widen to the point where water from the Red Sea and Indian Ocean will flood in, eventually splitting Africa into two distinct landmasses. This isn't just a hypothetical scenario, it's the predictable event driven by the principles of plate tectonics. Just like the Atlantic Ocean formed when Pangaea broke apart around 180 million years ago, the East African Rift is essentially a preview of what will eventually unfold. While it'll take tens of millions of years for the rift to form a new ocean, we're witnessing the earliest stages right now. Some parts of the rift are already below sea level, especially in the Afar Depression, where the land is sinking due to magma-induced subsidence. Satellite imagery shows that the rift is widening just a few millimeters per year, but over geological time, that slow, steady movement will add up, leading to a dramatically different geography. One day, the world may look at a map of Africa and see two separate continents, with a new ocean forming between them. This transformation will have profound effects on the climate, ecosystems, and biodiversity of the region. New coastlines will emerge, creating opportunities for marine habitats. But with this change comes challenge. Many communities rely on agriculture in these fertile areas, and the encroaching ocean will likely displace thousands. Volcanic activity could also increase, with rising magma leading to eruptions that threaten nearby populations. The region's changing geology could also shift wind patterns, rainfall, and access to freshwater, affecting everything from agriculture to daily life. The East African Rift is more than just a fascinating natural wonder. It's a powerful reminder of how tectonic forces are continuously reshaping the Earth, and it offers us a glimpse into the future of our planet's geography. As we witness this transformation, we're not just learning about the past, we're seeing the future unfold before our eyes. Dynamics of the Rift. At the heart of the East African Rift's extraordinary transformation lies the unrelenting movement of Earth's tectonic plates. The Nubian Plate, which makes up much of Africa, and the Somali Plate, representing its southeastern part, are slowly pulling apart at a rate of up to 2 inches per year. While this might seem like a small change on human timescales, over millions of years, this separation leads to dramatic shifts in the Earth's crust. What drives this process? It all begins deep beneath the Earth's surface, where convection currents, caused by heat from the core, create massive circulation patterns in the molten rock. These currents exert enough force to fracture the crust above, forming a divergent boundary between the Nubian and Somali plates. Unlike convergent boundaries, where plates collide and push up mountains, divergent boundaries like this tear the surface apart, giving birth to new landscapes. The East African Rift is like a land-based version of the world's mid-ocean ridges, such as the Mid-Atlantic Ridge. As the plates pull apart, magma rises from the mantle to fill the gap. As this magma cools, it solidifies into new crust, steadily expanding the rift over time. This process is both simple and profound. Magma weakens the lithosphere, causing it to fracture and thin. These fractures form fault lines and fissures, shaping steep valleys and dramatic escarpments. In places like the Afar Depression, active magma upwelling makes the process visible, creating everything from basaltic plateaus to volcanic cones. This isn't a new phenomenon. Around 180 million years ago, a similar boundary formed between what is now Africa and South America, leading to the birth of the Atlantic Ocean. The East African Rift offers us a rare chance to witness this process on land, where we can observe the massive forces at play above ground. And these forces aren't subtle. The region experiences frequent seismic and volcanic activity as tectonic stress builds up. In 2005, the Daboo event saw over 130 earthquakes in just a week, illustrating how quickly these tectonic forces can reshape the landscape. Volcanic eruptions are also a key feature, with some of the world's most active volcanoes found here. These eruptions release magma and reshape the terrain, while magma chambers beneath these volcanoes accelerate the rifting process by weakening the crust even further. Another fascinating aspect of the region is the formation of geothermal features, such as hot springs and fumaroles, where heated groundwater escapes to the surface. These features signal the proximity of magma to the Earth's crust and highlight the intense geological activity just beneath the surface. Over time, the combined forces of plate divergence, magma upwelling, and seismic activity will continue to widen the rift. Eventually, seawater from the Red Sea and Indian Ocean will flood the area, creating a new ocean basin between the Somali and Nubian plates. The Afar Depression, located at the northern end of the rift, provides a glimpse into this future. Parts of it are already below sea level, and cracks in the crust occasionally allow magma and groundwater to interact, creating temporary lava lakes and boiling mud lakes. In time, these features will give way to permanent water bodies, marking the birth of a new ocean. The geological processes driving the East African Rift are deeply interconnected. Plate divergence sets the stage, but it's the upwelling of magma, seismic activity, and the resulting crustal deformation that turn the rift into a constantly evolving zone of change. It's a stunning example of how tectonic forces shape the Earth, bringing both challenges and opportunities to the region's ecosystems and communities. Understanding these dynamics helps us appreciate the immense scale of the changes unfolding in the East African Rift. But these forces don't just reshape the land. They affect the people who live there. How will these communities adapt to an environment that's constantly being transformed by the restless energy beneath their feet? The answer isn't simple, and the changes will unfold over millennia, but one thing is certain: the East African Rift will continue to surprise us for generations to come. Stages of ocean formation. The creation of a new ocean in the East African Rift is a remarkable transformation, turning landlocked terrain into a vast body of water. This dramatic change is driven by the tectonic forces pulling the Somali Plate and Nubian Plate apart. It unfolds in three distinct stages. The first stage is the rift turning into a valley. As the tectonic plates diverge, fault lines and fissures begin to form. Magma rises through the thinning crust, triggering volcanic eruptions and earthquakes that reshape the landscape. Over time, the rift widens and deepens, creating long, narrow depressions bordered by steep cliffs, marking the start of the Rift Valley. Next, the valley slowly transitions into a gulf. As the rift continues to deepen, parts of it dip below sea level. This opens the door for water from nearby seas, like the Red Sea or Indian Ocean, to seep in. Eventually, isolated gulfs or narrow waterways begin to form. The Afar Depression offers a glimpse into this stage, with areas already sitting below sea level and showing signs of early water intrusion. Finally, the Gulf evolves into a full ocean basin. Over millions of years, the rift continues to widen, and the Gulf expands into a vast ocean basin. Magma keeps rising, continuously forming new seafloor, while tectonic activity ensures that the boundary remains active, further opening up the ocean. At this stage, the geology of the rift will resemble established mid-ocean ridges, and from there, it will slowly become a full-fledged ocean. So, when will all of this happen? It's a process that will unfold over millions of years, but it's happening right before our eyes. An extraordinary evolution driven by the unstoppable forces beneath the Earth's surface. The East African Rift is laying the foundation for a new ocean, and the world will never be the same once it fully forms. Imagine standing at the edge of a continent as it slowly splits apart, paving the way for a brand new ocean. The East African Rift is a rare opportunity to witness the early stages of this incredible geological transformation. While the changes happen too slowly for the human eye to notice, scientists estimate that in about 5 to 10 million years, a fully formed ocean will take shape. Right now, the rift is expanding at a rate of roughly 2 inches per year. That may seem insignificant, but in geological terms, it's a massive shift. The Atlantic Ocean, for instance, took tens of millions of years to form after Pangaea broke apart. The East African Rift is undergoing a similar process, following a well-known pattern of continental breakup. As the rift continues to grow, it will eventually separate the Somali Plate from the African continent, creating a dramatic geographical shift. A new island will emerge, made up of parts of Ethiopia, Somalia, and Djibouti, surrounded by the waters of the newly formed ocean. This will cause significant changes to the region's geography, altering coastlines in countries like Kenya, Tanzania, and Ethiopia. As the land separates, ecosystems will shift, and human settlements will need to adapt to new oceanic conditions. To predict the future of the East African Rift, scientists study similar events from the past. Around 30 million years ago, the Arabian Plate began to separate from Africa, creating the rift that would eventually become the Red Sea. At first, this process was marked by volcanic eruptions and frequent earthquakes, much like what we see in East Africa today. Over time, magma rose from beneath the Earth's crust, expanding the rift until it became an oceanic basin. A much older example took place about 200 million years ago when Pangaea began to break apart. Small cracks in the Earth's surface widened into large rift valleys, which later expanded into entire oceans, giving birth to what we now know as the Atlantic Ocean. These events demonstrate a powerful truth. Continents are always shifting, and the Earth is constantly reshaping itself. Whenever landmasses break apart, ecosystems undergo major transformations. Isolated environments allow plants and animals to evolve in unique ways. A perfect example of this is Madagascar, which split from Africa millions of years ago. Today, it is home to species found nowhere else on Earth. As the East African Rift continues to change, marine ecosystems will emerge in the new ocean, while climate patterns shift, influencing agriculture and water supplies. Scientists are closely monitoring these changes using advanced technology. Satellite imaging, seismic monitoring, and GPS tracking help measure the rift's growth in real time. Satellite interferometry, in SAR, detects tiny movements in the Earth's crust over time. GPS tracking * measures the exact speed and direction of tectonic plate movements down to millimeter precision. Seismic networks * monitor earthquake activity to detect underground magma movement and tectonic shifts. By combining this data, scientists can model what East Africa might look like in the distant future. They predict that the Afar Triangle will eventually break off, forming an island in the middle of the newly formed ocean. With advancements in artificial intelligence, remote sensing, and autonomous exploration, our ability to predict these changes is improving rapidly. The East African Rift isn't just a crack in the Earth's surface, it's a glimpse into our planet's ever-changing nature. By studying past events like the formation of the Red Sea and the Atlantic Ocean, we can better understand what's unfolding today. Thanks to modern technology, we don't just have to imagine these changes, we can track them in real time, watching as the Earth continues to reshape itself before our eyes. What can be done? The people living in the shadow of the East African Rift, particularly in the Afar region, have developed some truly remarkable strategies for survival in one of the most tectonically active places on Earth. These communities have adapted to the constant volcanic and seismic activity, shaping their way of life to thrive in an environment where the ground beneath their feet is always shifting. Water scarcity is a major challenge in this harsh landscape, but the locals have found innovative solutions. In the Afar Depression, volcanic steam vents offer a steady supply of heat, and the communities have learned to harness this geothermal energy. They collect steam rising from these vents and condense it into drinkable water, creating simple yet effective systems to purify and collect water in an otherwise arid environment. It's a brilliant example of turning what might seem like a hazardous element into a life-saving resource. Another incredible survival technique comes from the use of obsidian, a volcanic glass found abundantly in the region. The Afar people have developed a unique method for testing obsidian to ensure it hasn't been contaminated by volcanic gases. They test the mineral against natural benchmarks before using it to craft tools and weapons, ensuring its safety and effectiveness in a region where volcanic activity is a constant concern. While living in a seismic hotspot is undeniably risky, the East African Rift offers tremendous economic potential. The region is rich in resources like geothermal energy, volcanic ash, and valuable minerals such as gold, copper, and salt. In Ethiopia, geothermal fields are already being tapped to generate power, and as geothermal plants increase, they could not only provide clean, renewable energy locally but also on a global scale, serving as a model for sustainable energy production. Mineral extraction is another key source of economic stability for countries like Ethiopia and Kenya, which benefit from the rift's vast mineral wealth. The fertile volcanic soils in the region also attract farmers from around the world, eager to capitalize on the area's unique agricultural advantages. As the East African Rift slowly evolves into a new ocean, the environmental landscape is bound to undergo dramatic changes. The formation of a new ocean could significantly alter atmospheric circulation, shifting weather patterns across the continent. Areas that are now dry may see increased rainfall, making them more fertile for agriculture and boosting biodiversity. But on the flip side, regions that already experience heavy rainfall could see shifts in their climate, possibly leading to drier conditions. The creation of such a vast body of water will trigger a massive redistribution of heat and moisture, sparking widespread climate changes not just in East Africa but across the globe. This transformation will have profound effects on the ecosystems surrounding the rift, opening up new environmental niches and presenting challenges and opportunities for species to adapt, migrate, or even face extinction. The Earth has gone through these processes before, and it will do so again, continuing to evolve and reshape itself in ways that are as awe-inspiring as they are unpredictable. What do you think about these changes? Leave your thoughts in the comments below.